on programming on YouTube. You get to see a lot of videos on automation with robots in action. So hopefully you'll learn a little bit more about that today. So thank you.
Thank you very much. Well, good morning, everyone.
Good morning.
So I am the non-engineer that Dina was referring to, but I feel like I've been adopted by the College of Engineering and Computing. My father got his master's in engineering from MIT, so it's a little bit my DNA, but I chose a different path early on. But then I came back, and I've been in technology for the majority of my career. So it's great to be back on campus for the first time in a long time. By the way, this is my wife and my niece here in the front row. They were hoping to sit in the back row, but they got moved up to the front. And I'm speaking about a really 30-year passion of mine, and that is smart manufacturing. Smart manufacturing has been going on for decades. Okay, artificial intelligence, the term was first coined in the 1950s. So this is not new, but we have a lot of capability right now that we didn't have just a short time ago. And therefore, the industry is really changing, the direction is really changing, and so on. It's quite exciting. First, a little bit about Mitsubishi. So Mitsubishi Electric, as you can see at the bottom, is really a separate company from other Mitsubishi companies. After World War II, the US government broke up Mitsubishi. It was the biggest corporation in Japan. Even Toyota was much smaller. And Mitsubishi Electric is really the high technology part of the Mitsubishi family. So it's a separate publicly traded company. We do collaborate with other Mitsubishi companies. Mitsubishi Motors will obviously have all Mitsubishi controllers in it. But we are a separate organization, again, focused on high technology. Industrial automation, you can see that with the robot arm up there, is one of the biggest segments of the business. And that goes for other industrial automation products. CNC was mentioned, PLCs, programmable controllers, motion control. It's really one of the broadest lines of industrial automation out there. Energy and electric, also a big segment. Home appliances, maybe you're most familiar with the VRF ductless air conditioning units, the split units, or heat pumps. And I guarantee you heat pumps are going to overtake this industry in the future, but that's not what I'm responsible for. I'm responsible for factory automation. The other thing, really in the other category, is elevators. So Mitsubishi Electric makes the fastest elevator in the world, 45 miles per hour, and the smoothest elevator in the world. We also are the only ones that make curved escalators. So if you're in Chicago on Michigan Avenue, go to the Starbucks, the roaster there, and you'll be able to ride a Mitsubishi Electric curved escalator.
Can I interrupt just for a second? Can I get everybody who's sitting on the outside to squeeze in so that these people standing up can have a chance to sit down? Sorry.
No problem.
They use the reserve seats.
There are seats up in front too. I know everyone loves sitting in front.
Yeah, that's fine. That's the camera. That's the camera. Thank you very
Okay,
much.
do I get an extra 15 seconds? So this is a word cloud. I took this from a document just recently, and I put it in word cloud format. This is what customers, what companies are dealing with right now in the smart manufacturing space. Digital manufacturing, smart manufacturing, industry 4.0, whatever you want to call it, it is transformative. And there's a lot of things, you see data up there, a lot of things that customers are dealing with right now. So what is smart manufacturing? Well, this is not a definition that I got from the dictionary or from some other company. This is actually my definition, and it's really Mitsubishi Electric's definition. It's the collection, visualization, and analysis of data to optimize manufacturing operations. And that's really important to remember, and I'll kind of walk you through why this is important. But it's really more of an incremental approach to dealing with smart manufacturing, and it's really about data. That's why I asked the question earlier, Bina, about data analytics and data science. You're starting to see a lot of data science professionals enter this field, because when you're talking about predictive analytics and other things associated with this, data is becoming more and more important. Also, because of the market, because of the environment, because of the pandemic, there's a lot of supply chain disruption out there right now. Manufacturing is becoming more important. Logistics and supply chain more important in terms of investment. But why now? I mentioned that this has been going on for decades. It's an evolution. It's not, a big bang, if you will. I'm going to start on the right. There's a lot of business drivers right now and challenges. I mentioned supply chain disruption. The scarcity of labor is really driving people more to automation and doing it in a smart way. Sustainability initiatives are becoming more and more important to consumers looking for companies that have sustainability in their moniker. Remote workforce, okay? You need to do more with automation because you have more people working remotely. And then cybersecurity was mentioned earlier as well. But in addition to the business challenges, there's a lot of technology advances that make this possible now. Data storage, cloud computing capability was not there previously. Advances in sensor technology, being able to get data from the smallest device on the manufacturing floor. Advances in artificial intelligence, I'll talk more about that. And really the unsung hero is the network, okay? Because you've got to get data from the devices up to the ERP system, manufacturing execution system, and so on. So network speed, capacity, and convergence is critically important. So this is how I kind of view this. It's a continuum. It starts at the top, you collect data. And this can be IoT type data. You then want to visualize the data. You need to visualize it to understand it. We're kind of visual creatures, right? And that can be with a human-machine interface, or it can be with hard reports. Most importantly, you want to analyze the data. You can use Kaizen. You can use an 80-20 methodology. And then you want to finally optimize your manufacturing operations based on that analysis. And this is where AI comes into play. AI can help you automate that optimization process. But it is a continuum. And based on the results you get, you collect that data again and you keep improving your process. A little bit on the industrial Internet of Things. To make this all work, to make smart manufacturing work, everything's really got to be connected. And you've got to be able to access data from machines, from sensors, from controllers, as I mentioned, displays to visualize information, robotics and other mechanization, conveyor systems and other material handling equipment, manufacturing systems in total, and then finally, your overall infrastructure. So let's talk a little bit about some smart manufacturing applications that we run into all the time. Traceability, becoming more and more important, not only in medical device manufacturing, but automotive, and anywhere you need to give the consumer confidence that you know what you're doing, your products are being manufactured with a high degree of authenticity and so on, you get better accuracy, and like I said, you get improved consumer confidence. And I'll show you an example of how traceability is being used by a major tire manufacturer. Overall equipment effectiveness, am I running my machines at optimum productivity? Are the operators running those machines working at overall optimum productivity? So it gives you higher visibility to your manufacturing process and essentially more productivity and lower costs. Quality, asset, and energy management. Again, overall, what is the quality process? The same tire manufacturing company is not only doing traceability, but quality management using data analytics, and I'll show you that. And then finally, predictive maintenance. This has been around for a long time, but it's getting more sophisticated down to the individual component level, bearings, etc., in motors and gears. Higher availability and longer machine life. So everyone's trying to extend the life of assets. So this is Mitsubishi Electric's approach to smart manufacturing. We call it SMKL, Smart Manufacturing Kaizen Level. And you can see the stages on the left-hand side. Again, collect data, visualize data, analyze that data, and then optimize your manufacturing operations. However, what I want to introduce now is the scope of how you do this. And number one, you want to do it at the machine level. Number two, maybe extend it to a production line or a cell, then your full factory, and then eventually the entire supply chain. A lot of companies are in probably stage 1 and 2 right now. okay? The scope, I should say. And, but the important thing here is it's incremental. You can't do everything at once. You can't move to this upper right-hand corner immediately. There's way too much risk. And you really need to focus on where you're going to get the biggest bang for your buck. What problems are you trying to solve? What are you really trying to do for your customers? And so this is kind of the trajectory of where you want to move. Either keep it at the machine level and move directly up, and from those learnings, then maybe start to branch out in a diagonal format. And what is the technology that's really required to be successful in each one of these areas? Well, obviously at the lowest level, collecting data, you need good sensor technology. And then to visualize and maybe analyze data, you're talking about control equipment, display solutions, some application engineering, et cetera. And then really analyze and optimize, you're talking about, edge computing and finally artificial intelligence. So let me give you some examples. Who had coffee this morning? Okay. There's an 80% chance you had coffee that was where the beans were roasted by a company called Probat. So they make the coffee roasters. Okay, they have 80% of the market here in the U.S. German company, significant U.S. operations. This is one of their roasters right here. And what they're doing is they are measuring data such as time, moisture content, temperature, burner percentage, to arrive at a set of data, a profile for the roasting process, and then they can actually measure the quality of the beans against that profile and constantly improve the recipe. What they're looking to do is achieve a master batch recipe, and this is all done for their customers that they can then use for continued batches and continue to improve that as well to get the optimum roasted bean. Here's Continental. This is the smart tire manufacturing. This is really fascinating. So they've implemented smart manufacturing in at least 22 of their factories worldwide. They're number 4 in tire production in the world. They have, believe it or not, 4 million process variables that they're dealing with in terms of tire manufacturing. And over a year, after collecting all that data, individual data points, 27 trillion. 27 trillion. And they are taking that data and they know each and every tire, how it was manufactured, what the temperature was in the facility, all sorts of things. So if there's ever a quality issue, they can tie it back to that specific day that that product was manufactured and what all the conditions were. So this is good for quality and traceability. It's really quite outstanding what they've done. This is a company, Shoal IPN. They are big in the smart packaging area. So what they do is flexible packaging. So if you have cereal in the morning and there's a pouch in the cardboard box, they do the pouch. It's called form, fill, and seal. And they're a leader in this area. That's one of their machines in the upper left. And what they've done is they're using statistical process control and quality management to basically further optimize the machine automatically as they go through the manufacturing process. And this is a capability they're offering to their customers, which are the consumer products and food and beverage companies. And finally, this is a luxury car manufacturer that's doing smart energy management. They've been able to reduce their energy costs by 40%, increase their productivity by 20%. How? Because they are reducing their energy consumption, they're doing load shedding, demand management, and it's predictive demand management. So they're taking forecasts, even weather forecasts, they're reducing or improving fault detection and so on. So, this is really remarkable what they're doing in terms of energy management. So those are some examples. Let me talk a little bit about artificial intelligence, which is obviously to identify trends, make better decisions, engage in change management, and do problem solving. So this gentleman, if you can see him, kind of hard from my angle, but this is John McCarthy, associated with Stanford University. This is why I say AI has been around since the 1950s. He was probably the first person to coin the phrase artificial intelligence. And I always ask people when they throw out the term artificial intelligence, well, how do you define it? And if you want to be the smartest person in the room, ask that question when someone says AI. And it might throw them for a loop, or they might give you a pretty good answer. But really, his definition was the science and engineering of making intelligent machines. Wow, that's broad, right? And, you know, is it algorithmic? What is it? It's really hard to tell, but I think it's broad for a reason. And that is because it's all-encompassing. It needs to be broad. This is my favorite quote here. Artificial intelligence is making a computer do something you thought was intelligent until you learned a computer could do it. And that shows that we are taking advantage, or taking for granted, I should say, a lot of the advances in artificial intelligence that have happened over the past 3, 4, 5 decades. This was actually spoken by Niels Nielsen. Some of you might, again, know these names. This was at a presentation he made at Brown University in 1970. I don't know that you'll find that quote on the internet anywhere. This was given to me by a person that was in attendance at this presentation. He's now the director of the Mitsubishi Electric Research Labs in Cambridge, Massachusetts. So let's talk about the 4 levels of artificial intelligence. So basic AI is kind of that John McCarthy definition, you know, creating intelligent machines. It's kind of all-encompassing. Machine learning, one step up, is, I bet you've all engaged in machine learning, all of you, in the past several days or weeks. Anyone used Excel and did a trend line, set a trend line regression analysis? That's machine learning, okay? It's been around for years. And it's basically where you're measuring the correlation between a dependent and an independent variable in a linear fashion. So that's machine learning. Deep learning is quite different. It's more hierarchical. It's stacked comparisons. Best example I can give that I saw recently is if you have a toddler and they're trying to learn, for instance, the difference between a dog and a cat. The toddler will point to a cat, for instance, and say, dog. And you go, no, 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 that's a cat. And they are not just taking your words, but they're visualizing that animal and they're learning. And then the next time they see a dog, they say, dog. Yes, that's a dog. And over time, they learn, and we all learn, the difference between a dog and a cat, and apply that to any type of learning that you can imagine. And then finally, auto coding. You may have heard of this, where machines are actually doing basic computer programming and leaving the more higher end programming to a human. This is becoming more and more relevant as we go forward. There's an organization called OpenAI. Elon Musk is involved in that, and obviously auto programming is an area that is being pursued. I want to conclude by talking about the network wars. So this is the evolution of industrial signals. You can see back in the 60s and 70s, it was basically relay logic-based discrete I/O. In the 70s and 80s, analog was introduced. In the mid-90s to 2000s, we had the first industrial bus networks introduced. Of course, it was RS-232 and 485 serial networks. Mitsubishi introduced its CC link network. Rockwell had ControlNet, DeviceNet, etc. I was with them at the time. And then the 2000s, 2010s, everyone coalesced around industrial Ethernet, but different versions of industrial Ethernet. And then now what we see, and what's really, really important, is the introduction of time-sensitive networking. And I'll talk a little bit about that. Time-sensitive networking, a busy slide, I apologize. But you can see up at the top, we have an example. This is Mitsubishi CC Link IE field before TSN. And on the bottom is TSN. And I'm going to use the analogy of a highway. Before, with standard industrial Ethernet, you had maybe 6 lanes. You had all the traffic was put on the one highway, regardless of what type of car it was. So there's an emergency vehicle, there's an ambulance, there's a police car. They're stuck with all the other traffic, okay? And the buffering is really poor as well. And you can see some of the numbers there. But the analogy here is it's about 60 miles an hour, no more. Now with TSN networking, you have an 8-lane highway, and you're able to segment the traffic. okay? Your cyclic data, deterministic data for real-time control, those cars can go through, those message packets can go through at 100 miles per hour. They can swing. And you've got traffic cops that are letting certain things go through and not go through. Time-based is everyone shares a time clock. And that's consistent to make sure everything's synchronized, all the data is synchronized. And then transient data would be like your IoT data. Okay, we want to get it through, but it's not super urgent. It's for analysis, it's for optimization of the process. And then future OPC, maybe Profinet over TSN in the future. So hopefully that kind of gives you a good idea of what's going on with networks. But we believe TSN is going to be critical to facilitate smart manufacturing. So just in conclusion, I think this is a great industry. When I hear about the focus on data analytics and kind of making that cross functional or whatever within the university, I really think that's fantastic because data analytics and OT, IT convergence, operational technology, informational technology, is becoming more and more critical. So for the students in the room, this is going to be a really exciting area in the future. Manufacturing is returning to the US. When I was in Asia for 10 years, I would tell people, yes, China is the center for manufacturing, but everything comes around in full circle, right? And the US is starting to shine in manufacturing once again. And we will continue to do that because it's becoming a much more sophisticated field. So again, help us compete in an age of disruption. So that is my presentation. I'm happy to take any questions.
Questions for our speaker?
Bill?
Hi, Scott. Great presentation. This transformation is phenomenal, but in terms of the future, right? How's the workforce going to transform to support such a technological change?
That is a great question. So here's what I would say to that. Number one, you see a lot of people moving to automation because they have a problem with unskilled labor or people on the factory floor, people inspecting products by hand and so on. You see the move to automation. So you're basically shifting the labor problem to more highly skilled labor, which is going to be a bigger problem. So one of my chief concerns is we need to do a better job of getting more people into engineering and technical fields. But not only that, we have to interest them in manufacturing and automation and data science and data analytics. So it is a big challenge, Philip. But as Bina said, it's something that needs to be done in collaboration between industry and educational institutions. And we really need to start younger. We need to start maybe middle school level and get people excited. First robotics is an attempt at that, but there needs to be more of that. So, in my remaining time in industry and so on, and maybe even after that, one of my missions is to help to address the problem.
I have a question. On your slide on scope on the horizontal axis, you mentioned most companies were in the 1 to 2 range, but on the vertical axis, with the ABCs, where do you see most companies at on that? There we go. Yeah. On the stage.
Right. So I think a lot of companies are collecting data, but they don't know what to do with it, right? So you're right, Dave. We need to move up here, encourage companies to move up here, really before we do this. I mean, the stage is important because, from an incremental perspective, do one machine, and really figure that out, and then maybe move to a production line or sell. This is user-oriented. Obviously, OEMs can help with this, right? If they embed, like Shoal IPN, if they can embed smart manufacturing technology in their machine, that's going to help end users. But so many people are collecting data, they just don't know what to do with it. So I think it's important for companies like ours, don't overwhelm customers. And, we try and not even throw out the hype. I'm using some big terms here, but when we go talk to customers, we're much more about using these terms.
Scott, this is an excellent graph. On the vertical axis, looking at just the machine, as you go up to D, optimize, I think in your discussion really means AI.
Correct.
But I think before that, you need an internal culture of optimizing with human intelligence.
Right.
How far is the AI years from now to be ready to take that lead from the human intervention?
Yeah.
The automation, the feedback.
Again, it depends on how you define AI, Ron, but if you define it as automatically improving the process, it's in its infancy. In other words, automating this whole process, it can be done. You can do automatic analysis with AI. You can do automatic optimization. But a lot right now is in discrete stages where a human intervenes and says, okay, we're analyzing the data and we want to optimize, so we want to do these things. According to John McCarthy, that's still artificial intelligence. You're making machines smarter, but there is manual intervention. I think we're a ways off from really automating that entire process. That's been the dream for decades, to get to the point where the machine can say, I need to do this, I need to improve. It's being done in other areas other than manufacturing, but it's definitely a frontier in manufacturing that will come.
And unfortunately, most manufacturing environments are rather immature in their adoption of technology. Part of that's due to the technology that they've got on the floor.
Right.
The old equipment is just not going to be able to do it. But as time goes on, people are going to.
Yeah, absolutely. Yes.
At the level of the university, what will be the best thing that how we can train our students in both scope and stage? What would be the areas that you see industry needs the most, and that would be the case for us as instructors to train our students?
What industries would be the?
No, what industry will need from us, or let's put in this case, what level should our students have in the scope and stage before they get into industry?
I'm really excited about the approach to data analytics and data science here, because I think the kind of the cross collaboration between that department, which incorporates arts and sciences and so on, and engineering and computer science, that cross collaboration under the context of smart manufacturing, I think will go a long way to address what's required here, and then working with industry. So that's a great question.
Yeah, let me preface my comments that my background is metrology. Okay, so you talk about sensors here.
Yep.
I'm assuming that the sensors have to be calibrated.
Yes, I mean, I came
On some periodic basis.
for a period of time. I ran a machine vision company, so metrology and fiducials and basically calibration. Yes, very, very important when you're doing vision. Go ahead.
So typically there's a time span, 3 months, 6 months, a year, 2 years, whatever. Has anybody currently looked at an automated calibration system daily? My reason for saying this, if the calibration of the sensor goes like this,
Right.
your data is coming back and it's saying, well, I have to move my process because it's doing this.
Right.
But in reality, it's the sensor that's causing that.
Yep. So I don't know that I can answer that question specifically. Mitsubishi Electric, that's one business we're not in, is sensor technology. But like I said, I ran a machine vision company for a while. And there's been a lot of developments in terms of diagnostics when it comes to sensors. So I believe the capability exists to calibrate sensor technology on a regular basis. To your point, without that, it's kind of garbage in, garbage out, right? So that's a great point, but I don't know that I can answer your question specifically.
Scott, great presentation. You mentioned data science as a skill that the faculty can bring to the student body. But what would be your advice to the many students in the room as to what kind of skills they should be working on in order to enter the workforce and be productive employees for your company and others?
Yeah. Well, I think a knowledge of mechatronics to a degree, so both robotics, and maybe CNC. There were a couple at the Senior Expo. There were a couple student projects related to computer numerical controls and machine tools. Those particular products are going to be, and systems are going to be incredibly important moving forward. And they've been kind of islands before, but we're going to start connecting. Ron and I were talking about MT Connect, and we have what we call an IMA adapter and so on, just connecting the tools, connecting robots. Again, this gets back to the labor issue. So in addition to data analytics, data science, I would say understanding the mechanical piece would be very important.
Yes. So is there anything in the hobby level that college kids could get involved in?
At the hobby level. Well, this is a flyer here, but there's a company called ShopSaver up in Minnesota that makes routers, and they use pretty sophisticated motion control technology and so on. And I think that is a fairly inexpensive product that could be either something the university has or whatever that you can do design on and you can program and so on. It's kind of an entry-level type CNC, if you will. So that's just one thought I have.
So you talk about how companies are getting so much data and how they don't know what to do with it.
Yeah.
Do you see that this trend, as going more to optimization and more towards that AI, is company-based or industry-based?
Well, that's a good question. And I guess it's both. I mean, companies make up the industry, so it's going to be companies that are, there's so many companies in our space that are driving AI, driving towards true AI. The promised land being where you can, optimize a machine automatically based on feedback. There's a company that we partner with, Real-Time Robotics, out of Boston, Massachusetts, not Boston, Indiana, but Boston, Massachusetts. And they're actually using kind of a form of AI to improve the motion path planning based on learning. So it's really that deep learning aspect. So they're one company that's doing this, but it's influencing the whole industry, right? So I guess that's what I would say. Now, if you talk to the CEO of this company, this is where this gets interesting. He's a PhD, living in Boston. I think he went to MIT. And you go, oh, you're using AI. No, I'm not using. So he's got his definition of AI, right? And his definition of AI is where the computer writes new algorithms. And that, again, would lead us to a lot of what we're talking here in the ultimate stage, is where the computer can really function like a human and come up with an entirely new algorithm. I don't know that we're completely there yet. Yes?
I don't know if you can, this is quite a question or just a commentary. So I manage the computer science capstone, and our students, and probably all of engineering, constantly amazed at how creative they are. Got a lot of musicians and artists, but they're in a very technical degree program. And I didn't know over your life, your career, you see a lot of entrepreneurial, do you see a lot of creative people that are problem solving? I just wondered if you could talk about that.
I'll talk about innovation, which I think is what you're talking about. It's incumbent upon me and our company and all companies to create an environment of innovation. So the question is, how do you do that? And I've been personally thinking about this for quite a while, because I think innovation is key to our business. You have to first create a psychologically safe environment. People have to feel that they can take reasonable risks, and if they fail, not only are they not going to be punished, but they're going to be rewarded. So for taking that risk. Now, if someone's completely sloppy and just, that's a whole different issue. That's not what I'm talking about. But if someone, takes reasonable risks, tries to manage those risks, and comes up short, you have to reward them, I believe, to create that environment of innovation. You also have to have a process, I think. You can't You have to also create a very collaborative environment where people work not only within their teams, but across functions. So we're doing things to do that, to create organic teams within the organization to address problems. And a lot of it's management driving it now, but it's starting where the teams are forming on their own, which is a good indication that you're kind of getting there. We also created an innovation summit, and we did our first one last November. We bring not only engineers together, but we bring marketing and sales, voice of the customer, and we have a competition, friendly competition to see who can come up with the best ideas for future applications, even future technology, future solutions, things like that. So critically important to create that innovation environment.
Scott, I enjoyed your presentation. What I want to know is how far we're behind in this technology compared to China and the world, and how do we stack up? We always think ourselves as leaders in the U.S., but how far behind are we?
Yeah. The good news is, I don't think we're all that far behind if we're behind at all. I mean, China is, for a long time been the manufacturing center of the world, but they're leveraging a lot of technology from the United States, maybe from Japan, other more developed countries. So they've got the scale and the volume because primarily it's been low labor, right? Low labor cost. But in terms of implementing this, certainly they're doing it, but I think the really advanced work on robotics and other things in addition to data science is really coming out of the U.S. to a large degree. So
Yeah, I understand that. And what scares me, I worked internationally, and the U.S., it's the innovators of the world. And even Putin himself said, what do you like about America? And we're the innovators. But it's the theft of the innovation is the scary part.
It is. And China in particular, I don't know if you
Yes.
read this, but China much more than Russia. China much more than Russia is hacking and is stealing U.S. technology, trade secrets, and so on. And I've always thought one of the solutions to that is to keep things separated. And when you bring things together, particularly software development, really lock that down hard as you can. And that's easier said than done. But I remember when I was with my previous employer, we had a software development in China, but we didn't develop the complete animal. We would bring it back to the U.S. and we'd combine it with other pieces and so on for that very purpose of not allowing our intellectual capital to be exposed like that. So but we're still leaking a lot to China. I mean, I worked in China for 10 years in the region. And I can tell you this, that of course there's a lot of geopolitical issues right now, of course. But I always felt that once China was through their big development curve, there was going to be a problem because you have to be able to attract young entrepreneurial talent, the best minds. And unfortunately, given China's, quality of life, et cetera, to me, it's just not the optimum place for a young entrepreneur looking to grow a global business. Yes?
We worked on a program with a window manufacturer, and this goes back 25 years ago. They were collecting a lot of data. Somebody mentioned you collect a lot of data, then what do you do with it? They had failures. When you look at windows in, say, Florida to Arizona, different climates, they had different rates of failures. And they didn't know what to do with it. So we took all that data, going back 25 years ago, and we analyzed, although it was spotty data, because all the salespeople wrote failures, but they didn't note all the things. So we put it all together, came up with this algorithm, and then we showed them that this product is not going to work in dry environment, and this product is not going to work in the wet environment. So we had to tell them, then they adjusted their warranty offers. Earlier, they were giving, if you realize, some of you realize, earlier, Windows were giving lifetime warranty. And then they came up to 15 years warranty. And we proved to them statistically that in the 12th year, your company will go bankrupt if all these products fail, because they are on the trajectory to fail. So we used all this at that time. At that time, this notion of smart manufacturing didn't exist, so to say.
Right.
But statistical analysis of the data could be done.
Sure.
So that's what we did.
Yeah, fascinating, and 25 years ago. So you got to the analysis phase, and their decision was to change their warranty instead of optimizing the manufacturing process.
We went all the way. We changed their sealants and if you take a double pane window, we changed the sealants. We looked at their failure rates. We changed it. Now, we did one machine, but there were multiple machines in the production line. So we showed them how to do it.
Great.
So this, if you look at this chart, you would not just go one single column up. You will actually go diagonally up.
Yeah.
So you can never do, that's exactly right. That's the only way you go.
Right.
Yeah.
Great, that's a great example, thank you. So did you collect data after to prove that the optimization that was done was successful?
Yes, they have been doing it for last 15 years.
Great.
Yes.
Now again, the true AI would be that, based on the data on each window, you would optimize the humidity level and so on in the factory via the HVAC system, right? Just taking it one step further rather than a person having to do that. But that's a great example.
Thank you very much, Scott. I'd like to keep the fun schedule. The audience as well.